Mathematics can, and in fact have been used to model a wide variety of phenomena. Even vampires and zombies, believe it or not. The thing is, we mathematicians see math everywhere and believe that math can be used to prove or disprove almost any theory. I had a teacher who proved the existence of God using math, but we'll leave that for another time. When I was a graduate student, I was working on mathematical models of disease spread, and that was when I first came across a model of a zombie outbreak. It is not hard to see that a zombie outbreak is very much like a disease. In fact, in the past few years there have been many movies and TV shows where zombies are a product of a virus, a contagious disease. The same can be said about vampires, even though in popular culture vampirism is not so much seen as a disease. The coexistence of vampires and humans is also usually analyzed using models that were originally created to study the interaction between populations of predators and prey. But anyways, let's get to the point and see a simple model for vampires. Imagine Dracula was the first ever of his species on Earth. At that point, there were many humans and just one vampire. According to the novel, Dracula drank the blood of the same person for about a week, after which he finally drenched the life out of her and she turned into a vampire too. So after a week, there were two vampires. If we assume every vampire has this feeding behavior, then these two vampires would go on to bite one other person each and suck their blood for several days. And after a week, these two persons would turn into vampires too. Continuing with this pattern, after 3 weeks we would have 8 vampires. Then after 4 weeks there would be 16 vampires. 5 weeks, 32 vampires. And after 6 weeks, all the people in my slide would have turned into vampires. But really, I don't have that many people in my slide. So let's see how long it would take to turn all the world population into vampires. To do so, we can write a formula. We use V for vampires and T to count the weeks. So Vt is the number of vampires on week T. Since each vampire turns one other person, then by the following week there would be twice as many vampires. So we write our formula Vt plus 1 is equal to 2 times Vt. V0, that is at the beginning, when we started counting time, is 1, Dracula. Following our formula, V1 would be 2 times the number before, so 1 for a total of 2. V2 is 2 times 2, so 4 or 2 squared. V3 is 2 times 2 squared, or 2 to the third. V4 is 2 times 2 to the third, or 2 to the fourth. And as we keep going, we realize that there's a pattern. The number of vampires at any given week is 2 to the power of the number of the week. In other words, Vt, the number of vampires at week number t, is 2 to the t. Now, the world population is 7.7 billion people. So we need to find for which t this formula reaches 7.7 billion. In other words, find t such that 2 to the t is 7.7 billion. We could solve this mathematically using logarithm. We compute log of 7.7 billion divided by log of 2. But if you don't know what log is, it really doesn't matter because you could just as well keep on multiplying by 2 on a calculator, following what we were doing before. 2, 4, 8, 16, 32, etc. Counting how many times you press 2 until you reach or exceed 7.7 billion, meaning vampires ended humankind. Either way, we get that 33 weeks after the arrival of Dracula, humans would be extinct. You might think, well, yeah, but babies are born, so after 33 weeks, there will be some new inhabitants on Earth. And you'd be right, but at that point, you would have 7.7 billion vampires, so more than enough to transform any babies that could have been born in just another week. In a 2007 paper, upon analyzing this model, the authors concluded that vampires don't exist. Otherwise, humans would be long gone. However, other mathematicians came out in defense of vampires. asking the public to give them some credit. Vampires couldn't be that dumb that they would finish all their food supplies so recklessly. Of course, after humankind is wiped out, vampires are doomed too, with no more blood to drink for survival. So other models were proposed, ones that included a birth rate and considered that maybe not all vampire-human encounters ended up with the human turning into a vampire or even dying. Even a vampire death rate can be considered, thinking of all the badass vampire slayers out there. Several variants of these models were analyzed, extracting values for the parameters from the extensive existing literature. For many, it might seem a waste of time to study these unrealistic scenarios. However, they work very well for educational purposes, as young students are often attracted by these topics. Moreover, these models extend other existing models and can be used for realistic scenarios, such as dormant viruses. This also shows how flexible math modeling can be and how it can respond to a wide variety of biological challenges.